All right, today I'm going to try and explain a little more about the down angle or tilt, grinder base tilt, file tilt, whatever. I'm going to be talking about it in reference to files because it's mostly what I do, but it does work the same with a grinder. So to try and explain this, I'm going to draw it out on the whiteboard, but I need to explain what we're looking at. I can't draw the actual angle that would show this best. I'll put some descriptions up on the screen that show what I'm talking about. There's really three angles we're dealing with. Our filing angle, which would pretend this is a top plate looking from the top. Our filing angle, whatever you hold that file at. Our side plate angle, which is measured out on the outside there. And our top plate cutting angle, which is viewed from the inside. That's the one I can't draw. So to assist with this, I'll use, what have we got? I'll use this. So this would be a 9:1 scale of a RSLF cutter. So it's 9 times larger than what a 46 RSLF cutter is. It's got all the same angles and all the stuff, but there's a whole bunch of them here that I'm using for something else. But the angle we're concerned about, we view from the inside of the cutter, and it's this top plate angle here. It's really only going to be this half towards the inside that we're concerned about. We're not going to focus too much on what occurs through here to join the corner. So that's what we're going to talk about. So, what happens with files and tilt? All right, so we'll use a green text editor for our filing if we're flat. We're holding that file just vertical, 90 degrees across. I'll just draw a line randomly through it to represent that. If we use a still RS cutter for an example, what the angles we'd end up with are a 60-degree side plate. So it'd be 60 out here. Because that file is held at the same level, or that grinding wheel is brought down at the same level, we end up with 60 degrees everywhere. What I'll quickly do is just divide this top plate into a few sections. So with our file held level, or our grinding wheel brought down level, we'd have a 60-degree side plate angle when viewed from the outside. So if we had our cutter, it's not going to be a real good one, but you get the idea. Our side plate angle here would be 60. So we've got our 60 degrees marked up here. The top plate cutting angle would be 60 degrees there, there, and there. It's 60 degrees the entire way across. If we take our file or our grinder base and we tilt it, we change the way that it sits in relation to this cutter. So what I'll do is I'll use blue for this one. We'll come across, we'll try and intersect it at the same point. I know my lines aren't straight, but we're just trying to get the basic idea. Since we've exited the side plate at the same height, if we were looking at the center line of the file, we've exited the side plate at the same level. We would have a 60-degree angle here. So both of these examples would have a 60-degree side plate angle. What's changed though is the file, the center line of the file, or the grinding wheel if you're grinding, is now sitting lower in relation to that top plate cutting angle. So what changes? Instead of having 60 degrees here, we'll use 50 as an example. Now, if it's 60 on the outside, it's probably still going to be close to 60 here, as close as we could measure anyway. It might be like 58 or 59 or something, but it's still very close to 60 because it's exiting there. Through here, it's about 55. Sorry, I've written the wrong number. Through here, we're looking at about 55 or something like that, as it gradually increases from the inside to the outside to where it meets that side plate. So why might you do this? So the angle that actually has the biggest effect on cutting speed is this top plate cutting angle. Changes to things like the filing angle, if you change between 25 and 35, you're looking at maybe plus minus 5%. It really isn't much. If you even drop it from, if you compare say 30 and you drop down to say 10, it really is still a small amount. If you have ripping chains and you go and use them for cross cutting, they work pretty damn well. The reason for that, this is going to get a little bit technical and off track, but the reason that occurs why there isn't a big change in the filing angle is because while you do put more angle out here and it is a sharper point, it also makes the cutters pull outwards more. They tend to want to wander. So that's the major reason why milling chains are done with 0 to 10 degree angles. You're doing that to improve the finish quality on the wood. The finish quality improves because the cutters get pulled out side to side slightly less. So our right one doesn't get pulled as far right and our left one doesn't get pulled out as far left when they're going. It improves the surface finish. Because there's less side to side pull force on them, it's less friction and less work the saw has to do. So changing that angle doesn't have a dramatic effect on cut speed. Side plate angles, yeah, it's a bit different. Each to their own. Dog showed up to help out. Hello, Abby. The angle that has the biggest impact on the cutting speed is that top plate cutting angle. Like all things in life, it is possible to have too much of a good thing. You really run into issues when going below 50. It's generally been accepted from the beginning of all of this style of chain that sort of 50 to 60 range is where they work best. You can increase it to, you can change it to around 65 or 70 if you're having a really hard time in tough wood. You can get away with less in softer woods. But for the most part, it's always been regarded between 50 and 60. So even the early days of this, when the Japanese were testing 9AC cutters, chipper cutters back in the late 50s, early 60s, they were swinging them with a piece of wood on a pendulum to work out cutting efficiencies. That's basically what they found, and that's held true through most of the testing that's ever been done. All right, so I completely lost my train of thought there talking to the dog. So anyway, so that's the main thing I really wanted to discuss. How dropping that file angle or adding that tilt changes the relationship to the angles on the top plate cutting angle. That is the main effect we're getting. Now, we can change it. We could have the center line of the file up here and tilt it so it runs out in a different part. We could change that to be 85 degree side plate. It may be 80 through this section, maybe 75 over here and 70 here. That's something you can do to try and add a lot of durability to a chain while still keeping that cutting efficiency. So why can we get away with more angle here on the inside of the top plate than we can out here? It comes down to do with how chain cuts wood. So obviously our absolute hardest working part is our corner. It's the first part to impact wood. It's also got two jobs that are occurring here. The side plate, that's a very poor drawing of a side plate, but our side plate here gets the hardest job of severing the wood fibers. While it's doing that, this upper part of the corner up here is starting to peel out that chip. So this is where most of the damage occurs. If you go and use your chain and you go to sharpen it, you have a look at it, as long as you haven't hit anything where you've destroyed all the way across the top of the top plate or anything like that, if you haven't hit any foreign objects, usually the only part that's ever really worn is out on the very corner. Where through here, it does occur, but it's usually not as dramatic as what happens out there. So if you run for a few tanks of fuel and you keep cutting until it won't cut, generally the biggest damage is always going to be out there. You'll have a bit of damage across the top of that top plate cutting angle. But yeah, that's where That's where the true hard work occurs. So it's quite common to want to reduce that angle. Well, it is for me and the situations that I cut in. I like to reduce it. So instead of having 60, I might want 70 or 75. However, if you're cutting somewhere where 60 is not a problem, you might want to keep 60. Now, as we go across this top plate, the job changes. So if we look out here, view from the top, all that hard work's happening here. The side plate and across this top plate cutting angle, they're breaking off the fibers and they're starting to peel the chip. By the time we move along this top plate cutting angle, so we're about halfway down, this would be viewed from the top, it's no longer dealing with a chip that is still attached with the fibers on the side of the curve. All it is doing is continuing to plane that chip out. The work that occurs out in this section, which would be from here on out, is a lot easier than what occurs in there. So because of that, we can get away with running a lot more angle here out on the end. Like we could run 45 degrees out here if we can keep it over here at a reasonable angle. Say we can keep 60 through there. The very basics of what I'm trying to say is the angle out here does not affect durability anywhere near as much as the angle over there. And that's where the file tilt really gets its big advantage. But there is other parts to this. It's a pretty ugly looking cutter. Right, so the other thing that happens, and I can probably use a prop to show this, right there. So this is a scaled up version of a 46R. This is a scaled up version of a 46RM cutter. One of the interesting things as you look closely at these and you're trying to scale it up is the way they've formed the shape up through this corner through here. So that is what occurs as well when we file with a tilt. So in this case, still doesn't recommend RM or RS has a tilt. When you buy them, they all do. Every RM and RS chain I have is ground with a tilt. So what happens through this corner? As we change the angle of the file, we also start forming a shape running out towards the corner. We form like a small channel through there. If you watch my video I did a video called Chain Sharpening, File, Tilt and Diameter. You can actually see that being formed as I start doing it with the smaller 1364 round file in a Carlton 404 cutter. I painted the whole thing with texture and you could see what was being removed, and you can see that channel start to be formed up through there. How much of an effect this has, I don't really know, but what we're trying to do is that chip starts forming out through here, creating a curled shape through this section, helps get that chip to start coming across and curl down. I'm not sure how much of an effect it actually has, but it is something that occurs when you file with a tilt. So that's part of it as well. How much difference does any of this really make? Well, I can't do I gotta apologize because I cannot do the practical currently, and I don't know when I'll be able to do it. I think it's going to be a while. So I thought I'd at least get the theory side of it out there to get everyone pointed in this direction, but it depends on who you believe. Until I test it myself, I can't really say. So yeah, it really depends on what you're cutting, where you're cutting, the types of wood, the type of saw and everything else. It's truly hard to say if this will work for you or not. I do recommend that you try it. The important thing to keep in mind with this, if you're doing it with a grinder, is you cannot have the flat section of the grinding wheel coming down below the top plate. if you're trying to get the tilt to work. You want the flat section of the wheel to drop down below the inside of the top plate cutting angle through here, but not through the outside where the side plate is. That way you'll have that increased angle out here going across to a slightly higher angle over there. So you're replicating what can be done with a file. It's going to be different for everyone depending on your level of experience and what you're used to. I find this much easier to do with a file because that is what I mostly did. I never had much luck with grinding in this way. But yeah, so that's some of the basics of it. Hopefully it helps someone. I don't really know if it will or it won't. I took the lazy approach to this one. Did it while sitting on a chair with my feet up, so yeah. If you got something out of it, fantastic. If you didn't, you didn't. I will do a practical test on this, hopefully in the future. I have a bunch of different chains we can do this with, and I can just use the Vlorb guides. Their file guides have a little 10-degree thing on the end. I'll use a file guide so it's easily replicated by others if you like what you see, if it works for you or whatever. It allows other people to try the same thing as well. You can see what the results are like. I'll try it with some full chisels, some semi chisels. I've still got a 66 drive link hexa, and my hexa file has just about had it, so I may even do it with that. I've round filed one of them before and didn't really change much, so maybe I'll try it again, see if I get a different result this time. But yeah, I'll try and run through it with sort of normal size saws. We use some smaller stuff. It's probably no good me doing this with the 660 or something. It probably doesn't replicate what most people are doing. So yeah, hopefully sometime in the next few weeks I can do it, but I'm just not sure I'm going to be able to at this time of year. So we'll leave it at that for today.